So we received those questions in quick succession, and I thought, why not talk through them? One was, how would I add constraints or pin constraints to a grain setup? And the other one was, how could I add soft constraints to a soft body setup in Vellum? So let's talk those through and start with the soft body setup. For that, I'll just drop down maybe a box. Let's call this one soft bodies and dive in there. Want to leave that box as is and just attach a points from volumes. Wire that in. Set the point configuration to tetrahedral and the point separation to 0.32. Wire that in a copy to points and a sphere in the other slot. Set the sphere to be a polygon of a frequency 4 and a uniform scale of 0.15 like this. And when I wire this in the copy to points, highlight this, you can see I just created a bunch of spheres here. And what I want to do now is create another sphere down here, and I want to pull it through and into those spheres. And when we do this, it should behave as if it were attached to a spring, so it should wiggle around a bit. Let's set that up by just copying the sphere over here. And then in the beginning, let's just ghost this and highlight this. Let's just move this sphere down a bit to, say, -6, keyframe it, move to frame 48, and set another keyframe, this time to 0.1. So we move it up, like this. Next, let's configure our Vellum soft bodies. Wire in the sphere here, and drop down another one. Wire in the copy to points on this side here. So the only trick there is here is to add another constraint in between my sphere and the first Vellum cloth here. So let's pipe that in here and just wire up the remaining slots here and set this constraint to pin to target. And what that will do is it will try to follow this target's position if we drop this down, check match animation. And if we want to have this springy behavior, let's set the pin type to soft and then dial back its stiffness here to, say, really low value, such as 5, and increase the damping a bit. Now we're all good to go and set, so let's drop down to merges. So we'll merge on the one hand the geostreams of both those Vellum configurations and also their constraints. First one is used for the geostream, second merge is used for the constraints, and then we'll drop down a Vellum solver and wire in both the geostreams and the constraints here. And within the Vellum solver, let's just decrease the constraint iterations for now. This is a really simple setup, we don't need as many. And also under forces, let's make sure gravity is set to 0 so stuff doesn't fall down. Let's save this quickly, keep our fingers crossed, and hit play. Let's just switch off the ghosting and watch this again. Yeah, and maybe we could increase the damping on this pin constraint here, so the sphere doesn't wiggle as much. But basically that is your standard setup for pulling off something like this, using Vellum soft bodies as dynamics objects. Let's dive back up, and let's do the grain setup, which is even simpler. So let's uncheck this and drop down another geo, call this one grains, dive in there and drop down a box again, just your default box like this, and to that I'll attach a Vellum configure grains. Wire this in. Gonna set my grain size to 0.2, check create points from volume, highlight this, and maybe check jitter and leave the jitter scale at 1. So I have a bunch of grains here. I want to do that for the grain that will pull through here as well. So adding a single point using the add node, just check the point here and highlight this. So we see the single point here. And in the beginning, let's just move that down to -0.8, set a keyframe, go to frame 48 and move this up to 0.1. Keyframe again, go back to the first frame, and let's drop down a Vellum configure grain 2, wire in our single point and highlight this here so we can see we have this single grain here. Let's just increase its size a bit to 0.3 like this. And also what I want to do, I want to group those. So before we go into the Vellum grains, I'll just attach a group sub, set this to points, and call this one, well, maybe collider. And make sure all of my single point is in that group. Let's check. Yeah, it's in there. And also after the Vellum constraint. Again, let's merge those two streams. Again, 2 merges, one for the geostream, one for the constraints. First one is for the geostream, second merge is constraints. And then again, drop down a Vellum solver, which will wire in the geostream in the first and the constraint stream in the second slot. In here, for grains, what I want to do, increase my substeps and decrease my iterations. Again, that the grains get stable, and under forces, make sure my gravity is set to 0 like this. Let's save again, highlight the Vellum solver and try it like this. and you see nothing is really happening because we haven't taken care of the pin constraint. And with grains, what I want to do is I want to do this within the solver so that it checks for this pin constraint and executes the pin constraint each solver frame in here. So I'll dive in the solver and drop down a Vellum constraints in here, wire this in the force output, and in here set up my pin constraint as previously. Just make sure to check that we execute this constraint each frame, then set it to pin to target. And this time we want to only influence this group here. That's why we created this collider group. So let's just set the group type to points and check collider here. And in the pin type, set this one to soft, check match target animation, and then again, dial back its stiffness. In this case, maybe to 50. Head back up, again, save this and resimulate. And we can now see that the strength of my pin constraint is not strong enough to pull this through this mass of grains here. So let's increase that by diving back in the solver and maybe setting the stiffness to 500. Again, heading back up and resimulating. Still not strong enough, so again, let's try tweaking this into 5000. Again, back up and resimulating. So now we're looking exactly at the behavior that we wanted. So that's your grain setups with constraints. Let's clean this a bit, tidy it up. But those are your basic two setups for either pulling grains through each other or soft bodies. So rather simple, straightforward, and actually quite fun to play with. Weirdly, as soon as something has jiggly physical behavior, it kind of always works in animation. So that was a quick one today. See you next time. It's cheers and goodbye.